Hello, and welcome to the Sales Service Plus on-demand instructional series on Zoeller wastewater pumps. I'm Jeff Williams, and I'll be presenting the first in the series, Selecting the Right Pump for the Job. Wastewater pumps are divided into four general categories. The pumps are sorted according to the size solid that can pass through the pump. The industry standard is a regularly shaped spherical solid. The first category is effluent and dewatering. This includes some pumps and effluent from septic tanks. The pumps in this category can pass from 1/2 inch to 3/4 inch maximum spherical solids. The next category is sewage. By code, any pump servicing a system with a water closet must pass a minimum of 2-inch spherical solids. The third category consists of larger commercial and industrial pumps referred to as non-clogs. These pumps can pass either a 2.5 or 3-inch spherical solid. And the last category contains grinder pumps. Grinder pumps have a cutting system that reduces the incoming waste stream to a slurry of small particles. One important note: the grinder pump is designed to reduce human waste and paper products to a slurry. It's not designed to grind sticks, leaves, or other items not normally found in the sewage waste stream. Zoeller offers a total of 24 standard effluent pump models. They range from the M53 sump pump to the 2 horsepower 189 high head pump. Zoeller has 17 models of 2-inch solids pumps. They start with the residential models 264 and 267 and go all the way up to the 7.5 horsepower 600 series non-clog pump. Zoeller offers 14 models of grinder pumps, beginning with the residential 803, 805, and 807, 1/2, 3/4, and 1 horsepower grinders. We have the 818, 819, and 820 1 through 2 horse commercial grinders, the 840 heavy-duty commercial industrial reversing grinder, which is the only grinder that reverses itself every cycle, and we round out the line with the engineered product 7100 series 3, 5, and 7.5 horsepower grinders. Zoeller utilizes 2 different cutting systems that each work on the same principle, but are designed to work in their intended applications. The first system is used in our residential and light commercial systems from the 803 to the 820 grinders. It features an extremely sharp rotating stainless steel cutting blade which turns against a stainless steel cutting surface. This system will easily reduce everything from latex items to denim down to very small particles. The second system is used in our larger grinders. It features a stainless steel 2-sided star-shaped cutter which allows the same cutting action when the pump's direction is reversed. It's designed for heavier duty cutting challenges found in larger commercial and industrial applications. It is important to choose a pump that uses an impeller design that best fits your application. There are 3 basic impeller designs. The first is the vortex impeller, the second is the semi-open impeller, and the third is the enclosed impeller. The vortex impeller has multiple shallow vanes that do not extend to the bottom of the pump body. As they spin, they cause water to flow out of the pump body, which in turn causes water to rush in to fill the voided space. In addition, there is a vortex created, which also helps to draw in the liquid being pumped. The solids rating of the pump is equal to the space between the impeller and the bottom of the pump body. The design has the ability to pump any size solid up to the maximum rated solid without jamming the impeller and cause the pump to fail. All Zoeller pumps, 2 horsepower and under, utilize a vortex impeller. We've made the assumption that all wastewater may contain some degree of solids in a variety of sizes, and a vortex impeller offers the best design to prevent these particles from causing pump failure. The semi-open impeller has two vanes which extend to the bottom of the pump body. The solid's capacity is equal to the space between the two blades. This is an efficient design, and most pumps using a semi-open impeller design will outperform a pump using a vortex impeller. However, small solids can become trapped between the impeller and the pump body, jamming the impeller and causing pump failure. This is especially true when pumping waste that contains stringy material or a wide variety of large and small solids. Enclosed impellers are limited to solid size that can fit between the top and the bottom of the impeller. They are used in higher horsepower pumps where efficiency is important to limit the cost of operation. When selecting a pump, it is always best to choose a type of pump that was designed for the application. This will result in the best efficiency of operation and the maximum pump life. Each pump design has its own characteristics that make it suited for an application. We'll start with effluent pumps. In general, effluent pumps produce higher heads and lower flow per horsepower than other types of pumps. They have smaller discharge lines ranging from 1.5 to 3 inches. Depending on the flow requirements, effluent pumps are used as sump pumps, processed water disposal, parking lot or truck bay dewatering, and for pressurized septic fields and any other gray water applications where the solids are 3/4 of an inch maximum. Before we move on to sewage pumps, it's helpful to understand an important factor in solids handling pumps. In order to keep solids suspended while pumping through a discharge pipe, a minimum velocity of 2 feet per second must be maintained. The flow rate to maintain that velocity increases as the diameter of the discharge line increases. For a 2-inch pipe, the minimum flow rate is 21 gallons a minute. For a 3-inch line, that flow rate is 46 gallons a minute. And for a 4-inch flow line, the flow rate is 80 gallons per minute. This factor has an effect on the design of sewage pumps. Because sewage pumps often discharge into large diameter piping systems, the pumps generally have a higher design flow rate and lower head capabilities than effluent pumps. These characteristics enable the pumps to maintain the required minimum flows and velocities in larger diameter pipes. The sewage pumps will have a minimum 2-inch or larger discharge. Because the pump has a high flow rate, the amperage of the pumps are generally higher than those of effluent pumps. The motors tend to be larger and power cords heavier. These pumps can be used in residential or commercial sewage application, dewatering where the demand for flow is higher than can be met by an effluent pump, and really any low head, higher flow application. Because the pumps can pass large size solids, they should not be used in effluent pumping to drain field unless there is some kind of pre-filtering of the effluent from the septic tank. The introduction of flushable wipes to the sewage waste stream has increased the demand for true grinder pumps. Because the discharge pipe is smaller than sewage pumps, the flow required to maintain minimum velocities in the discharge line are lower. For this reason, most grinder pumps are higher head and lower flow than sewage pumps. The horsepower ratings for grinder pumps range from 0.5 horsepower up to 2 horsepower. Most grinder pumps today have adopted the axial cutting system we showed you earlier. You should use grinder pumps on any sewage application where items may be present that could cause pump failure in a regular 2-inch solids pump. These include residential and commercial sewage systems, any public restroom, schools, and medical buildings. You should not use a grinder for applications to grind sticks, leaves, or other non-sewage items that may enter the waste stream in parking lots or other drainage applications. It's also not recommended to use a grinder pump to pump to a septic tank. Using a grinder pump with a septic tank can artificially raise the total suspended solids and harm the natural action of the septic system. It is important to match the type of wastewater pump to the application for which it was intended. This will give you the most efficient pump for the application. It also helps to eliminate unintended problems that might arise, and it does help to maximize the life of the pump itself. Now, once you've selected the right type of pump for the application, the next step is to select the right model. The next lesson in our series will cover pump sizing. If you have any questions about today's presentation, please send them to me at gwilliams@salesserviceplus.com. Please include your name, your company name, and a phone number where you can be reached. Hope to see you at our next lesson on sizing.